slide.
There we go. No worries. So again, my work with the district has included a lot of different things, including numerous lake studies and overseeing the district's monitoring program. So now lately I serve as the 9 Mile Creek Watershed District's district engineer. So I get involved in a lot of different projects for them. And I'm excited to be here tonight to share some of the recent monitoring information with you. How do I details. So you can just go. There we go. Thank you. So tonight, I'll be sharing some information with you on some of the changes that we've been noticing in our climate and weather patterns and how these changes seem to be impacting our lakes. I'm going to start by just presenting just an overview of the water monitoring program, and then I'll provide a brief summary of the changes in our climate that are happening or expected to happen in Minnesota. And then we're going to explore how some of these changes and some of the recent climate extremes that we've been experiencing have been impacting our lakes. So to start off, I'm just going to talk a little bit about the district's monitoring programs. So this is a map of the watershed district. It's about 50 square miles, in the Southwest Metro, includes 6 different cities. And on here we have, the district has a pretty robust monitoring program. We monitor streams and we monitor lakes. So shown on this graph are as dots the red dots are what we call our watershed outlet monitoring program stations. And so these are places along the creek where we measure flow and we measure water quality. And so we measure flow continuously. And so we, at any given day and time, we should, be recording what the flows are in those locations. We also monitor the stream and about 8 locations that are shown as green dots. And at those locations, we're collecting on a generally monthly basis, data on the flow and also the other characteristics of the stream. And then we also monitor lakes, many of our lakes, and many of them are shown up here in this map. So with regard to lakes, we monitor about several lakes every year. Usually it depends, but usually maybe between 3 and 6 lakes. And those lakes are selected every year based on a number of different things, including, lakes that we've done a recent project on. Maybe it's a lake that we're going to do a study on in the future that we need the information, or we generally also just like to keep up on our lake. So periodically we want to make sure we get back to every lake every once in a while just to see how it's doing. When we're monitoring our lakes, we collect a lot of different, we analyze for a lot of different parameters. And the 3 that are kind of the most common for lakes in Minnesota are phosphorus, chlorophyll A, and what we call Secchi depth transparency. Phosphorus is an element, it's a nutrient. You find it in the dirt, and sometimes even we'll use it as fertilizers to make your plants grow. But it also can be an issue in our lakes, and it essentially feeds the algae. And when you feed the algae, then you get a lot of algae and it reduces the clarity in your lake. And so those are why those 3 parameters are so typical when we're talking about lake health. We also collect data on chlorides, nitrogen, which is another nutrient that really impacts our lakes, dissolved oxygen, and temperature. And we do some other parameters as well, but these are the primary ones. The district also collects a lot of data on the health of the aquatic communities in our lakes. And this is really an important part of our program, and it's been part of our historic program. And it's not something that everybody does. And so I think it's a really neat set of data. So this graphic is showing many of the different factors as related to lake health. And these in this blue rectangle here are the ones that we monitor. So we do monitor macrophytes, which is a fancy word for aquatic plants or weeds. We try not to call them weeds, but I know that's what others call them. That's important because it provides a good habitat for fish and other aquatic life. We monitor phytoplankton and algae. So we look at not only how much is there, but what species are there. And we monitor zooplankton as well. So the zooplankton eat the algae, the fish eat the zooplankton. So we really try to monitor what's going on in that whole system. We also collect information on the water quantity because that has an impact on how our lakes are doing. And so we do monthly monitoring at 29 lakes or water bodies and 6 groundwater wells. So we hear a lot about climate change on the news, and often that's at a national or a global level. But what does climate change look like here in Minnesota? So I'll provide a brief overview on some of the changes we've been experiencing or expect to experience that impact our lakes. I'll also discuss some of the climate extremes we've experienced in recent years. One of the biggest changes that we are seeing in Minnesota is that Minnesota is generally getting warmer and wetter. So this is a really busy graphic that the DNR has developed, but it's got a lot of information in it on this idea that we're getting warmer and wetter. The average temperatures in Minnesota have warmed by 3 degrees Fahrenheit since 1895. And we're getting more of our rain. We're getting more rain, and it's coming, more and more of it's coming as large events. There's a 20% increase in the number of 1-inch rains that we get. That's a pretty sizable rain. There's a 65% increase in the number of 3-inch rains. So that's a really, that's a really good storm, and those are coming more frequently as well. So not only are we seeing more rainfall, are we getting more of our rain in these big events, but our really extreme rainfalls are becoming more frequent as well. So this is an interesting timeline, and it just shows that historically the number of these historic mega rain events has increased recently. So you can see in the timeline, and you can see that they've happened throughout our history, but you can see definitely there's a lot more of them in recent years. And we see that on the news, and we see some pretty disastrous events that have been happening. In addition, increased heat waves are part of that warming that we're experiencing in Minnesota. We expect that these heat waves will increase in severity, in coverage, and in duration. And climatologists also expect to see an increase in drought. So an increase, we expect that with potential for longer dry spells. And this is a photo here of, that's Arrowhead Lake, or a portion of Arrowhead Lake that, we are walking around in it this fall. So that lobe was essentially dry, after the drought last year. So what have we observed in recent years? You may recall a few years ago, before our world was sort of upended by COVID, that we went through a very wet spell in Minnesota. In fact, 2010 through 2019 was the wettest decade on record in Minnesota. And so this image here that we're seeing on the left is just a snippet from a publication that the National Weather Service had. And it was in 2016, we had the wettest year on record at 40.3 inches. And then sure enough, 3 years later, we had the wettest record, a higher one, the wettest record at 43.17 inches. And so still officially 2019 was the wettest year on record. And so this was a lot of rain. And it was I think, people were definitely noticing it, and we were hearing about it on the news. 2022, so following that, 22 was a pretty normal year. And then things dramatically turned the other way. And so you may remember the summer of 2021 and last summer, and it's a little hard to see. Is there a way that we can move that bar? Yeah, great, thank you. So you may recall that we've had drought conditions in the summer of 2021 and the summer of 2022. So here on this image on the left, you'll see that here in where we're in a severe drought condition in August of 2021. And the image on the right here is at the end, October of 2022, we are in extreme drought here in 9 Mile Creek Watershed District. Oopsie. I lost him. Oh yeah, there we go. So not only was it dry, but it's also been pretty hot. So if you might recall, it's a couple summers ago already, but summer of 2021 was the hottest on record. It started off, and the heat started early. It was unseasonably warm in late March and early April. And then the heat continued throughout the whole summer. It is the hottest summer on record, and the average daily high that year was 85.6 degrees, that's pretty hot. Yeah. Summer of 2022, again, it was a very dry one, extremely dry. And this one also started hot as well. We had a warm May. We had hit 90 degrees on the 12th of May and the 28th of May. And then we had an unusually warm June as well, with 8 days during June where we were above 90, which came in at 11th of all time out of 150 years. And we had a set record heat on June 20th last summer of 101 degrees. So as a person involved in managing water resources, this weather roller coaster has been extremely interesting. And admittedly a little stressful at times, right? Look around the room at some others that we've been going through this. So how did our lakes handle that stress? One significant impact that we've seen during this weather roller coaster has been the wild fluctuations in our water levels for some of our lakes. So wet weather that we were having and through 2019 and the years before that, combining that with a high groundwater condition that we had in 2019 meant that we saw some really high lake levels in our landlocked lakes. We hit a record high water level in several of our lakes. They're all landlocked: Lone Lake and Shady Oak Lake in Minnetonka and Indian Head Lake in Edina. So that was pretty remarkable. This photo here on the left is from Lone Lake. This is a little bit hard to see. This is from the spring. So the spring of 2020, and comparing it with this one from last fall. And basically what I'm trying to show here is the dock that you see on the right is completely underwater on the left. I had a funny, one of my colleagues I just saw today, he was just telling me that his family, historically, they would take a family photo on that dock every year as their kids grew up. And in 2019 and 2020, they had that tradition came to a halt because that dock was underwater. So I'm not sure if they're back out there now, but I just thought that was kind of cute. So this is another example of a wild fluctuation. This is a graph of water levels, of monthly water levels from the year 2000 to 2022. And what I've circled here is, and this is for Birch Island Lake, which is a very shallow marsh lake in Eden Prairie. And we saw in 2019, that lake rose 9.2 feet in that year, which is pretty wild. And then it dropped 11 feet since then in the last 3 years. And so that's just, we're just seeing, our lakes are seeing some really big changes. So how do these climate extremes that we've been experiencing, how do they impact lake water quality? Well, the answer is it depends. The impacts on, the thing about lakes is they all have their own story because there's so many characteristics that impact how it acts. These are a few of them. The size of the lake certainly makes a difference. The size of the watershed, so how much water is getting to that lake and how much of that watershed is developed and impervious. That makes a big difference on the amount of pollutants that are coming to a lake. The depth of the lake is a really significant thing, and the bathymetry and what that looks like under the water. The lake outlet, if it has one, you know, those that don't have one act very differently than those that do have an outlet. And the size of that outlet and the configuration of the outlet can really change how a lake functions. And then also some of the lakes, we have several lakes in our district that are right on the creek. For example, Bryant Lake or Lake Smetana or Normandale Lake. And that really influences how those lakes function as well. So I'm going to spend probably the next 15 or 20 minutes talking about specifically three of our lakes that 9 Mile Creek monitored in 2021 and 2022. And just talking a little bit about how they fared in this drought condition. You know, as you can see here, we have a number of lakes in the watershed, and they're all very different, but generally we have numerous lakes that are shallow, and many of these shallow lakes are in a setting that's pretty highly developed. It's you know, we've got highly developed communities. Some of our shallow lakes are in a setting that aren't highly developed, which is pretty nice. And then also we have some deep lakes. And so what I'm gonna start off with Southwest Anderson Lake. I'm gonna talk about that lake. This is a shallow lake that has a pretty undeveloped watershed and small. And then I'm gonna talk about North and South Cornelia Lake in Edina. And that shallow lake has got a pretty densely developed watershed. And then I'm going to talk about Bush Lake, which is a gem of a lake down in Bloomington that's deeper. And so I'm going to focus on those three for the next few minutes here. So this is a photo of Southwest Anderson Lake that's in Eden Prairie. It's located, and this is it's a shallow lake, and it's kind of tucked away off to the side, doesn't get a lot of, you know, activity or lake use. It's located right here. You can see it's just south of 494 and just west of 169. So you can see it if you drive by, but you might not even know what you're seeing. And this is part of the Anderson Lake chain. And so there's three lakes. Southeast Anderson is in Bloomington. Southeast Anderson flows to Southwest Anderson. Over here in this graphic, you can see that on the right. And then that flows north to Northwest Anderson Lake. And then ultimately that water flows to a storm sewer system that's up by like Highway 169 into a MnDOT system there, and then goes into the South Fork of the creek. So Southwest Anderson is 110 acres, shallow, about 8 feet maximum depth. It's got, you can see here in with the yellow outline there, that's the watershed. So it's pretty small watershed compared to the size of the lake. And there's not a lot of developed land within that watershed. And that's really a good thing for when we're thinking about water quality of that lake. 9 Mile Creek Watershed District conducted a water quality improvement project on these lakes back in the 2000s. It included a lake drawdown of Southwest Anderson Lake in 2008, follow-up herbicide treatments in that lake from 2009 to 2013, and then an alum treatment of Southwest Anderson in the fall of 2012. So first of all, so I mentioned I'm an engineer. I like bar graphs. So if you don't like bar graphs, just hang with me for a bit here. You'll see a few tonight, so this is a bar graph, and these red lines are showing phosphorus concentrations in the lake. And this is over time. So this the first monitoring data point is 1988, and it goes through 2021. And you can see that dashed black line there is the Minnesota state standard for shallow lakes in our ecoregion. And the standard is they want the phosphorus level to be less than or equal to 60 micrograms per liter of phosphorus. And so you can see in 2021 that we met that standard. It was well below that level. So this is sort of similar graph, but this is Secchi depth. So a Secchi disc is this little thing that you can kind of see a picture of it there, but it's the thing that you hold and you drop it down into the water. And then you basically drop it down until you can't see it anymore. And that's the Secchi depth. That's the transparency depth. That's how we measure that. So this is a graph showing the historic Secchi depth transparency. And you'll, oh yeah. Let's see, how do we do that again? More. And then what? Hide. Thank you. Thank you. So yes, you can see that in 2021, the lake did meet the Secchi depth goal of 1 meter. And this is a similar graph, but this is for chlorophyll A, which is an indicator of algae. And this is showing that the algae concentrations, summer average algae concentration in Southwest Henderson Lake was quite low and met the standard. So this lake did really well in 2021, even though, and I was a little worried about it because it was, as we mentioned, it was really dry in 2021. And I got a call from one of my field staff one day, I think it was in July, and he's like, I don't think we can get out there. It's so it was shallow enough where they were having trouble getting their boat out there. And so I was really glad to see these results coming in, that it was resilient against the dry conditions.
2007 was dry too, so it's.
It looks like it did well, fared well on that. Yeah.
2020 might be political.
Yeah, that's a good point. Randy?
You want to add that these are summer averages.
Yes.
So we monitor, it's not just one data point, it's monitored 5 or 6 times throughout the year. It's an average between June and
September. Yep, thank you. Yeah. So this represents a general condition from that summer. Yeah.
What caused the spikes in 2011 and 12?
Yeah, great question. So, and I forgot to mention what. Oh yes, thank you. The question was what accounts for these spikes that we saw in 2010, 2011, and 2012. We saw it in phosphorus, we saw it in chlorophyll, and we could see that the clarity was really poor those years. So there was so that we did a lake drawdown before this, and then but that's what's really happening here is in that lake at that time there was a lot of phosphorus in the sediment. And so when you get in that situation, when your oxygen levels get low enough, that phosphorus can get released out of the sediment. And that's called internal phosphorus loading. And that was happening in this lake.
Was that as a result of the drawdown?
I don't think that was necessarily a result of the drawdown. I think that we could dive really deep to I don't think that's the case. I think that problem was there before, but it wasn't as prominent as it showed up in those 3 years. But we did do an alum treatment in the fall of 2012, which was planned beforehand. And you can see that it really, improved that. So that was to kind of took care of that. What an alum treatment does is it basically, you put this aluminum compound into the water, and the phosphorus typically is bound to iron, but when it has aluminum available, it binds to that instead. And so, and when it's bound to aluminum, it can't release it. When it's bound to iron, it can get released when the oxygen gets low. So the aluminum is a more permanent bond. And so that's how that works. And so we saw that really made a nice difference here in this lake.
Is there a downside to doing that? Let's say, well, let's do that every year. Yeah,
I think, and it'd be expensive to do it every year. That would be the primary downside. I also think you wouldn't need to do it every year. The alum treatment will, it depends on the lake. There's a lot of things that depend in this science, but you'd usually get 10 years out of an alum treatment, sometimes more, sometimes less. So I think it's more you just keep an eye on it, and if you start to see it happening again, then you'd consider doing it again.
Yeah.
Yes. Oh, thank you. Yes.
Are you seeing similar results for Normandale Lake? I know you're not going to cover Normandale Lake, but you did an alum treatment there in like 2018 summer.
Yes. Yes. The question is, did we see similar results in Normandale Lake? Because we did an alum treatment in 2019. So yes, we've seen, this is pretty pronounced. And so I wouldn't say we saw anything quite that pronounced, but I think what we saw in Normandale is that in the last couple of years, the last 2 years during these dry years, the water quality was good. And I think if we hadn't done the alum treatment, the water quality wouldn't have been good. We would have seen spikes coming. The oxygen conditions were such that we would have seen a lot of that phosphorus being released from the sediment. So we would have seen a different. Okay. So yeah, I think we've seen a positive result from that alum treatment in Normandale.
Normandale never really had high phosphorus. It wasn't like this. We didn't get the high chlorophyll A.
Yeah, we've never seen that chlorophyll response in Normandale. There's some years where there's been some. Normandale, the phosphorus tends to stay right kind of around the standard, but there was a few years, here or there where you did see a big spike. The chlorophyll, you don't see those big spikes in chlorophyll in Normandale. So I mentioned we also monitor the aquatic community, the health of the aquatic community. And so this is a graph that's just depicting how healthy our plant community is in the lake. And so this is the number of plant species that were observed during these. So we go out there and we monitor in June and we monitor in August. And so you can see in the more recent years, 2020, in 2021, the number of species was highest on records. And so that felt really good. That's good news. Also interesting, we found several new species that had previously not been observed in that lake in 2021. The bearded stonewort, the hooded arrowwood, and the floating pennywort. And what I thought was sort of interesting in the context of a change, climate extremes, this one, hooded arrowhead picture is here. This is a rare species in Minnesota, and it's listed by the DNR as threatened. And so it was pretty interesting to find it in our lake. Again, it was the first time observed in Southwest Anderson, and this is a drought tolerant plant. And so that's why we saw it there in 2021. It thrives on these exposed mud flats. And so I just thought that was just sort of an interesting tidbit that we did see some different plant species because of the dry conditions. So yeah, so Southwest Anderson is fared pretty well during the drought conditions. Now we're going to jump up to Lake Cornelia and Edina, and I would say this message is not as happy and positive. This is one of our shallow lakes, and again, but we have many shallow lakes, and the story is somewhat similar for many of our shallow lakes, that are pretty high, densely developed. So this is a lovely picture of Lake Cornelia. It's a lake that's located in a popular park in the city, and it's got a nice fishing dock here. It also looks like this, and this one, I don't know if you can see it, but it also looks pretty green pretty often. And so we're working to improve that. This is, again, there's a north basin and a south basin, and they're both small and quite shallow. And this has a big watershed. So you can see that yellow outline. That's the outline of the watershed. It's about 1,000 acres. And that all drains to these two little small shallow lakes. And you can see it's pretty densely developed. We have Southdale in there. We've got the hospital complex. We've got Highway 62. And so it gets a lot of loading. It does have an outlet, and the flow from this lake flows south to what's called Lake Edina, and then eventually to the North Fork of 9 Mile Creek. And historically, the water quality has been pretty poor, unfortunately. So this is a photo from 2021. As we talked about before, it was really dry. So we had really low water levels in midsummer of 2021. And in 2022, we were especially low throughout the summer. And this is a photo of a portion of the lake, a wetland kind of on the fringe of the lake, and it was essentially dry. We had portions that were dry, and we had very little flushing. There wasn't a lot, it wasn't raining. So there wasn't water flushing through there. So these are the phosphorus graphs for Lake Cornelia. We've got North Cornelia on the left, and we've got South Cornelia on the right. You can see that in 2021 and 2022, the amount of phosphorus in the lake was really high, especially in North Cornelia. You can see that it actually gets better. South Cornelia is quite a bit better, but it's still exceeding this standard. These two lakes weren't the worst on record for these for these 2 years, 2021 and 22 weren't the worst on record, but they certainly weren't, what we wanted them to be. And what was especially concerning in 2021 and 2022 was these algae concentrations. So you can see they were the worst almost the worst on record for those lakes. And that was really apparent when you're going out there. And not only was it just a lot of algae, it was a lot of blue-green algae. So we've seen in this lake, and we've seen significant increases in the blue-green algae in recent years. This graph here is showing, so this graph is showing for the times when we are out monitoring, this is showing concentrations or counts of blue-green algae. And so blue-green algae is, well, first of all, it's a concern because blue-green algae, it's also called cyanobacteria, and it can create toxins. It can create algal toxins. And when you have a bloom, and they can, be a health risk to pets, to humans. And so there's certainly a concern. And so what's interesting about it is there's not a standard though. There's not a standard. And so what we do to sort of gauge the risk that is we use some guidance from the World Health Organization on health risk. And so you'll see here that we've plotted up the counts of these blue-green algae in comparison with these guidance of low probability and moderate probability of adverse health effects. And so you can see in recent years, we've been above that threshold and into the moderate probability of adverse health effects quite often. And so that's something that's certainly gaining our attention. So why is this happening? Well, there's several reasons why it could be happening. I think part of it is that we have less aquatic plants out there in recent years, and so the plants aren't competing for the nutrients, and the blue greens are thriving. But it also, what is part of this related to our changing climate? This is a super interesting slide, I think, because what we're seeing is not only in Lake Cornelia are we seeing an increase in these blue-green algae, but we're also seeing it in other shallow lakes in our watershed. And the numbers are different. You'll notice that the scale on all of these graphs are different. So some of them, have much lower counts, but you'll still see this general trend is maybe not the right word because we don't have enough data points, but we're seeing a similar thing that we're getting increases in the recent decades. And I'll say in most of these watersheds, the watersheds aren't changing. These are developed watersheds. So there's not big changes that are happening here other than, climate and weather. So what causes blue-green algae blooms? Nutrients are part of it, a big part of it. Phosphorus is, oh, sure, question?
Is the monitoring system over there, is that working now? Or is it,
The which system?
is it working at all, the monitoring system that you put in over there?
Oh, sure. The one that the construction that we constructed last year?
Yeah.
Sure. The question is the system that we installed last year working? And so the watershed district, in partnership with the city of Edina, installed a filtration system in Roslyn Park. And so that's right between, there's an upstream kind of pond, and then there's North Cornelia, and there's a parking lot, there's a disc golf course and a play lot. And so we installed this filtration system that pumps water from Swim Pool Pond, the pond upstream, or Lake Cornelia, and sends it through a filter to take out phosphorus. And so that finished construction in July last summer. And we spent a portion of the summer then trying to just go through system startup. And so it's working, and we have some preliminary results, but we unfortunately weren't able to run it for part of the summer because the water levels in Cornelia were so low that we weren't able, our pump wasn't getting enough water. And so it was really unfortunate that we didn't get to test it for a longer period of time last summer. So I'm looking forward to the ice to melt and to get it started again. So again, what causes blue-green algae? So we've got the nutrients are the primary source. Phosphorus is still considered the primary driver for blue-green growth. High sediment release of this. We talked about internal phosphorus loading that we saw in Southwest Anderson. That can be a really big source of phosphorus for these cyanobacteria or blue-green algae. And what's interesting about these blue-green algae is they can regulate their own buoyancy, which is unique. Like other algae can't do that. So they can like decide, they can move up and down in the water column to go get the food. And so that's so that gives them this competitive advantage. They also can what we call fix nitrogen. And so if there's not nitrogen available in the water, they can essentially fix it from the air, and they go through a process where they fix it. And so that's also an advantage that they have over other algae. Another cause of these blue-green blooms is a light limitation. So these blue-green algae do well under low light conditions, and other algae don't do as well. So they have another advantage there. Sometimes they can also thrive in the winter under cold conditions. And so they sort of have this dominance in these conditions. And temperature is a big thing. Increased temperature, they operate better in a warmer temperature. And so that's another advantage for them as our lakes are warming up. And they can also, another thing that happens in our lakes is when the temperature increases, the lake stratifies for longer periods, which means, when you go on a lake and it's cold down by your feet and it's warmer there, that's stratified. You've got different layers of the lake. And so when that happens, it can stratify stronger and for longer periods of time. And again, the blue-green algae can kind of, zoom up and down as they need to get the food, and other algae can't. Yes.
Is who's
Droppings?
Does that have cyanobacteria in it, or?
No, that would be, the question is, does goose droppings have cyanobacteria in it? Goose droppings would have like a fecal coliform or other bacteria in it. It wouldn't have cyanobacteria in it. Goose droppings is a source of nutrients, and so it could feed the algae in the lake, but it wouldn't have it directly in it. So we're seeing more of these more blue-green algae, more blooms. Why is this increasing? Well, what's interesting is there's not a blue-green algae and these cyanobacteria and algal toxins. It's sort of a new thing in science. So there's a lot of research happening because we're seeing it not only in Minnesota, but in, certainly other parts of the country. And it's becoming a bigger public health concern. And so there's just a ton of research happening on it. And so, but we are finding that warmer temperatures are part of the problem. And that's part of what we're seeing in Minnesota. So, it's hard to say if they're linked, but it seemed like there probably is a link there. The warming waters increase the length of time that these blooms happen. Again, the warmer water is these blue-green algae operate at optimum conditions at that temperature, so they can kind of outcompete the other algae. And again, the warmer water can lead to that stronger stratification, and they can their buoyancy allows them to move up and down as they need to get the food. And then also the below average precipitation that we've been seeing in recent years probably made things worse just because there's minimal flushing. A lot of times when you're getting rain going through there, it's flushing it, it's diluting it, it's flushing it downstream, and that didn't happen as much in 2021 and hardly at all in 2022. So there was a few things against us that really made blue-green algae have a strong year last year. Another interesting thing that we saw was, I couldn't not talk about chlorides, but chlorides were especially high in the last couple of years too. So chlorides in our lake, is problematic. It's hard on the aquatic life. And what we saw in 2021 and 2022 is the chloride concentrations were high in the spring, which is pretty typical because you have melting and you have salt from our roads getting into our lakes, but it stayed there last year, and it really was about flushing. And so the chloride wasn't flushed out of these lakes, and so it stayed high most of the year. Okay, well, I'm going to zip through. So that's that's the situation. I think the blue-greens are certainly a concern.
Did you do it out in those lakes?
We did an alum treatment in Cornelia in the spring of 2020. And so,
Even so,
even so, and that's a very long story and discussion, and we can talk about that, but I don't have time to talk about it right now. So, but yeah, so it helped, but it wasn't enough is the short answer. Okay, we have to zip through this. I guess Bush Lake. So this is a deep lake, a lovely lake in West Bloomington. It's about 188 acres in size, and this one is deep, and it's got a maximum depth of 35 feet. It's got a relatively small watershed. It has a large littoral area, which is the area where plants can grow. So a lot of it's shallow, even though part of it is deep. This has a pumped outlet to Southeast Anderson Lake, and it's really a nice lake. There's a swimming beach, and it's historically had really good water quality. We monitored this one in 2022, and the water quality was excellent. So you can see here, this is the phosphorus, and the phosphorus concentration in 2022 was, about 15 or below micrograms per liter. Similar story with Secchi depth was we met the standard, and that looks, the clarity is really good. And with algae, the algae levels were also really low, well below the standard. So that lake really looked really great in 2021 and 2022, even though there was a drought condition. We monitored the types of algae, the phytoplankton, and what we found was there was a more balanced algae community that we're seeing in this lake compared to some of our shallow lakes like Cornelia. So you can see here that we had green algae, we had diatoms, the cryptonomads, and those are really nice food for zooplankton. And so it was a good healthy community. We did have blue-green algae, but in low concentrations. And the plant community was also really healthy. And you can see here that the number of plant species was around, close to 30 or a little bit above 30. So a really nice plant community in that lake. And so conclusions. So these recent climate extremes that we've experienced, they resulted in some pretty significant fluctuations in lake levels. The water quality response to these climate extremes, it differs by lake. And it's going to depend on many factors. We saw in our shallow lakes, they struggled. That was really stressful for our shallow lakes. And they didn't do as well, especially those shallow, I should say, the shallow lakes that have these, large, highly developed watersheds. We saw a lot of algae problems. Again, our blue-green algae concentrations are increasing in recent decades in some of our lakes. The extreme heat and the dry conditions created these favorable conditions for the blue-green algae in 2021 and 22. And these deep lakes or shallow lakes with the low development pressure were more resilient to the climate extreme, the drought that we had in the last couple of years. And with that, are there any questions about any of this or, other things, other projects that the district has going on?
There's a high population and the growth of homes and stuff and hard surface areas. Is that causing more problems in the wetlands up to lakes?
Sure. The question is the development and all the impervious surface causing more problems with our lakes? I think that's a huge part of the stress on our lakes is so much of our watershed is developed. So we have a lot of imperviousness. That means every time it rains, all of the pollutants, just come flush right into or oftentimes go right into our lakes. And I think what we're seeing is that some of the lakes can handle it better than others. And so, especially our shallow lakes, they just don't have they don't have the resilience to handle that. They're already stressed out. They were probably natural wetlands to start with. And so when you are putting too much water in there with too many pollutants, it just is challenging. So those are hard to manage. And I think it's tricky because the expectation, I think the public's desire certainly is for them to be better. Yeah.
Let's take a online question.
Sure.
We do not have any online questions.
Okay. No, there we go. Great.
Okay.
Yes.
I'm just curious about the deeper lakes.
Mhm.
Is it because there's more water and it's deeper, it doesn't get as high?
Why
They're faring better?
Yeah, deep lakes act differently and they, so right, there's more water, so there's more dilution essentially for the pollutants, and they also, act very differently where they stratify, and they usually stay stratified all summer. And so even then, sometimes when you have that internal phosphorus loading happening at the bottom of the lake, that still happens in deep lakes, but it stays down there because the lake isn't mixing. And so as regularly. So that helps with the deep lakes. There's a lot of different factors that help make those deep lakes more resilient. Yeah, I think that's generally that. I don't know, that answer your question.
Yeah, it does. I mean, I really didn't know,
Mhm.
and so it's interesting that the water doesn't mix, it kind of stays.
Yeah, and it's pretty interesting in these shallow lakes. And we get out there and monitor, every few weeks or every month and so we see during, whether we monitor shallow or deep lakes, we monitor temperature and dissolved oxygen at, each different the layers throughout the lake. So we see how it changes. And then you can see you can look through the data and see like, oh yeah, this shallow lake was stratified. And then the next time it was mixed. And some of these shallow lakes probably mix several times a week, depending on the wind and depending on how much water is coming in. And so they're just kind of always mixing, and then that phosphorus that comes out of the sediment, it gets mixed up with everything. And so it feeds the algae. There's just so much in those shallow lakes. There's just so much water. There's so much pollutants coming in from the watershed, and potential for that to be coming out of the sediment that is just kind of like an endless source for the algae. Not endless, but plentiful, I guess.
Thank you.
Mhm. Sure.
Can you tell me more about the filter that's been installed between, did you say North and South Community?
Yes, I can tell you a lot about that. How much time do you have? Let's see. What do you specifically, do you have a question or?
Is it charcoal? Is it?
Sure.
Yeah.
Sure. So the goal of that filter is to send the water through it, and we want it to pull out phosphorus, specifically dissolved phosphorus. And so the media, so there's these 3 chambers, and we've designed it with these 3 chambers as sort of an experiment to try different types of media, filter media. And so we have, and what's special about this filter is that the goal is to filter a lot of water fast. Some of these filters, just if you can't treat a lot of water because it's sort of slow. And so we've chosen filter media that have a higher porosity so you can get water through it. And they also have metals in them. So one of them has an iron compound, one of them has an aluminum compound, and one of them has what's called CC17, which is more of a calcium compound. And that one might also have iron in it as well, I believe. But so we're just trying these 3 different media to see which work best. And so we will be monitoring that pretty intently this year and next year to understand, how each of those is doing. And one thing to note, we do have on the upstream side of that, as water comes in first, it goes through what's called a pre-treatment filter. And that's an anthracite filter. So that's a carbon-based filter. And that filters, it's like the first filter. So it filters out the bigger stuff. And then, by the time the water gets through that, it's a little cleaner, so it can go through the other filters. So if you go in there and if you go there and you look in there, you'll see that back filter is what the anthracite pre-treatment filter. And then there's these 3 different chambers. So, yeah.
I have a couple of questions. Where does the chlorophyll come from? And how does duck weight factor into it?
Sure. The question is, first one is, where does chlorophyll come from? And so chlorophyll is a pigment, it's an algal indicator because it's a pigment that's found in algae. And so the algae, so it's essentially coming from algae. And so then it's in algae essentially, can feed and reproduce and grow and die. And so there's this constant cycle of algae that are there. Second question was, say it again.
How does duckweed?
Oh yeah, how does duckweed factor in? So duckweed is a small floating aquatic plant. Mike can probably answer this even better than me, but so it's you know, it's a part of a shallow lake system. It's again, it's a small little floating plant that floats on the surface. It takes in phosphorus, and it's just part of the system. I guess it's one of the system. It's different. It's not an algae. It looks kind of like an algae, or it looks kind of ugly sometimes. But it's not, it's a plant.
Can it overgrow so that algae doesn't bloom?
It can overgrow. It can overgrow, and it can cover, it's, you know, you can see it covering the surface, and that can affect light availability, right? So the plants underneath that and algae can be impacted by the limited light. So it can, you know, play a factor in that. Go ahead. I didn't have anything else significant.
You mentioned that some of these lakes, maybe pre-development, were wetlands.
Mhm.
So is Cornelia an example of that, which is what I've heard, but
Yeah, I wish I would have. I have some cool progression of historical photos of Cornelia, and I could send that to you. But yes, so really Cornelia was a wetland, and you know, as development happened around it, it changed, and you know, the roads went in and this and that, and we put in an outlet, and so it acts more like a lake now, because you know, in a way that it has standing water and it has a controlled elevation. But yeah, I would call that, you know, historically more a wetland.
I'm still interested in this, why not more,
Why not more
in
alum?
Cornelia, yeah, did you decide now that?
Well,
internal phosphorus is not?
Sure. The question is, why not more alum in Cornelia? So if we are going to be doing more alum in Cornelia, and when we first did that alum treatment, we split the dose, because if you there's potential that you could have too much of an impact on your pH of your water if you go in there with too much. And so we split that dose. So we knew we were going to have to come back. But we're finding some interesting things related to, so what we do to figure out, oftentimes we'll see the data, and the data will say, oh, it looks like there's an internal loading problem, but we also will go collect sediment cores and then analyze that first like 10 centimeters of sediment to see what's happening in that, and where is the phosphorus. And sometimes it's attached to iron bound, it's bound to iron, and sometimes it's organic, it's still like decaying duckweed and decaying algae and such. And so we're looking at that, and we might have to sort of tweak how we do the alum treatment, because a lot of it's now in organic form. So that's kind of interesting, Randy.
So with the alum with iron.
So right, so we're considering like a treatment. It's kind of new and different, but it would be an alum treatment with iron. And essentially then we're saying, as we're trying to push, we're alum would basically, any phosphorus that is available to be bound, you'd bind it up. And then as that other organic form converts, then you have iron there for it to grab onto. And if you can keep the oxygen high enough, then it will. So this also involves oxygen.
What form of iron?
Oh, I don't know right now. Keith would know. Yeah.
Normandale Lake, by the appearance of it, the drawdown didn't do what it was set out to accomplish. And now every year it's covered with plants throughout. With dredging that lake, I mean, it's basically 50 years of sediment in there. But what are the plans to clean up that lake?
So the question is about Normandale Lake and about the drawdown, and that and I didn't. Did you say the drawdown did or didn't do?
I don't think it did. I live at the block there.
Sure.
For about half a year.
Okay.
Plants should turn it out. It's real bad.
Sure. So the concern is that the plants are there again, and the question is whether dredging is an option. So dredging is an interesting part about that lake is it was constructed in the late 70s, and it wasn't a popular thing with the Army Corps of Engineers, and they put some restrictions on what could be done with that lake. And so essentially managing that lake so they will allow things that when you're managing that lake as if it's a wetland, they allow things, but they're not they won't allow dredging, at least on the west half. And so there's some pretty strong restrictions there. We haven't looked at it beyond that, you know, just given that restriction, we haven't looked at that. So, you know, I think that, you know, we've seen, and I didn't talk about Normandale tonight, but we, you know, we'll be providing a summary of the Normandale Lake monitoring results at the early May workshop, I believe.
Yeah, we'll be doing a summary of all the water qualities in
Mhm.
2022, which will include a portion because we monitored Normandale Lake.
Yep.
So it won't be Normandale Lake specific, but Normandale Lake will be part of, you know, the presentation.
Right.
Well, it's a quick follow-up, lost my train of thought here. My neighbor, you probably know, is a retired scientist from University of Minnesota. Did a study and said that most of the sediment, the bad stuff that's coming from into Normandale Lake is a result of the River Golf Course. Are you aware of that?
This is you. Well,
I'm that. Oh, there's.
like, I think you guys are talking about each other.
Actually, that was a data.
Yeah, so I think what we found there, so we did some follow-up on that and monitoring from Braemar, and part of it was a little bit of a mix up on the data, so which was on our end, and so it wasn't as pronounced. What was thought to be potentially a big amount coming from Braemar was actually coming from the other side, the other creek. But we did find that some, you know, certainly some phosphorus is coming and nitrogen are coming from Braemar. So it was interesting. We did follow up monitoring, and, you know, I think we found some useful information.
It's not coming from Braemar.
It's not a huge, Randy?
And I just wanted to clarify, it wasn't sediment, it was nitrogen.
Yeah.
Yes.
And one other thing I wanted to clarify is the drawdown that we did was for a specific plant, early pondweed. And the goal of that was to allow the native vegetation to have a better opportunity to take hold. It wasn't to reduce macrophyte quantities in the lake. I mean, actually, we wanted a more holistic, diverse vegetative population in the lake, which actually takes out or sequesters phosphorus and will help the clarity of the lake. So, I mean, realistically, the drawdown, I would say, is pretty good for reducing.
Yeah, we can talk more about that at that presentation if you are interested, but I think we felt that it's been successful in that it's reduced. We have had a reduction in that curly leaf pondweed, and the native plants are doing well, and that's really important in that lake. If we didn't have those native plants doing well, we would, you know, there's a greater potential for more algae in that lake. You know, we are still seeing some surface, you know, there's some surface, whether it's duckweed or water meal or filamentous algae, that certainly is unsightly at times. That's still there, and that wasn't really a primary objective of our project.
Actually did a good job of it.
I think that I think the duckweed's gotten better, and it's been interesting because the low flow conditions in the last 2 years have been, the lake has looked, you know, from a phosphorus standpoint and a clarity standpoint, the lake has looked pretty good in the last 2 years, but yeah, there's still, that doesn't mean there's not, you know, floating vegetation that's unsightly.
All right, well, we are at 8 o'clock, so thank you so much for all of your questions, everybody, both online and in the audience. We do have our business cards back there on the desk. If you have more follow-up questions, you want to talk to any of us about that, we can give you our card. We can stick around for a little bit, but again, thank you, Janna, and thank you everybody for coming.